This is part 3 of the 2020 trial, and continuing on from question 25D. I don't know if I know I already mentioned this, but I don't know how much detail I went into. So in this question, we're looking at the allowable load. Now, I will tell you that a lot of people tried to find the shear stress. So a lot of people just simply didn't read the question. They didn't look at the units. There were lots of things to help guide you to say that even if you didn't hear the word, if the allowable stress is not to exceed 150 megapascals, right? The fact that the answer says down the bottom, allowable load, and in kilonewtons, all of those things are there to help you. Remember that we can use megapascals and millimeters, millimeters squared, millimeters to the power of 4, right? We talked about this in the last recording about the grease units, that we're allowed to use those units as a time-saving thing. Okay, so in this situation, we know that the formula for stress equals force over area, so we can rearrange that formula to get force equals area times stress. So if we know what the area is, now we do have to use a very small amount of geometry to turn the diameter into area. So it's, let's say if we use pi r squared, which is what kids like to use these days, it'd be 25 pi, which is about 75 millimeters. 150 multiplied by 75 gives us, what was the answer? 35 kilonewtons, something like that? Yeah, something along in that ballpark. Okay, so this question here, this question was answered terribly. I gave you 1 mark if you did an attempt that was just not shocking. Like, there was no one who answered this even close to well, but you know, some people took an attempt at it, and I gave you a mark for labeling something, and I could see at least one happy face. Okay, so let's have a look at what the answer is supposed to be. Now, I'll be honest, I think I took this question off a recent trial, and I thought, oh, I know I'd made a thing about saying that I wouldn't test anything that was not in the Year 12 textbook. And I did have this picture of a Welds somewhere. I don't remember where, though. Let's have a look. There we go. Okay, so in the 2017 paper, I did check that it is in fact in the textbook as well. I should have got that open for you guys as well. Again, could take me some finding in the book. There we go. Okay, so I did check that it was indeed in the book. So let's see what they have to say here. Well, they have a figure, and they've described the figure. They said a cold roll plate has been welded. Grain growth around the weld lowers the strength of the weld. Okay. So when we weld materials, we often bring about some significant changes to the parent metal. Right, so the difference between welding and brazing is that welding melts the parent metal. That's a great question. If I was writing an exam, if you're listening to this in the future, that's a good question I might put in a future exam. What is the difference between welding and brazing? Right, welding melts the parent metal. The area around the weld is called the heat affected zone. In this area of the heat of the welding process may cause some changes to the grain structure of the material. Okay, so if we are welding cold welded plate, the heat affected zone will exhibit some unstressed grains, as the welding process will heat the plates near the weld above the material's recrystallization temperature. Generally, non-ferrous metals will be softened around the weld by the welding process. While the mild steel is very easily welded, it will also suffer grain growth near the weld, which will soften the cold rolled plate. High carbon steels, okay, I'll come back to that in a second. So what they're saying here is elongated grains are going to be stronger, right? They're going to be stronger and harder because they're, what's the process that turns metals into, I think I've already said it, cold working, gives us elongated, stronger, harder grains. Yeah? That's a fair assumption, right? If you hadn't shown it as cold worked, this question I literally just took from the HSC, which we'll see in a second. But also if we, so it says up here that it's been, if it's related to the one earlier, it's probably forged, or machined is I think what they said. What did they say above? Chassis rolled. There we go. Mild steel rolled. Okay. A large reinforcing plate. Yeah, I mean it's not in the same question, so that's a fair. Even then, it's still a reasonable assumption. If you hadn't shown it as elongated, I probably wouldn't take off the marks. It's reasonable to assume that most things are. If you showed it as normalized, that would also be fine. Right, so if you said normalized grains, I don't really mind as long as you take an assumption, a reasonable assumption. Right, this subject's all about reasonable assumptions. Keeping in mind that no one was even close, right, for these marks this year. Right, maybe next year will be different. Okay, so what we have here is we have equiax grains at the center of the weld, and then we have long columnar grains, right? Column-like grains towards the end of the weld. This is because of the heat wanting to transfer quickly into the rest of the metal. The rest of the heat is being sucked away. Then we have larger equiax grains, smaller equiax grains. Then we have the unaffected metal. Okay, we'll have a quick look at what the HSC answer says. Right. So what it shows here is equiax grains, columnar grains with chill crystals on the outside edge. It has recovery crystal. I don't know how to pronounce that. Okay, so we have grain growth in this area. So we have large grains becoming smaller grains, and then we have the original cold worked microstructure. Right. So like I said, I took this from the question without any additional. Now, what I did talk about is they did say in the answers for this question, it does say that you can have multi-pass welds. And I think in the past I've shown multi-pass welds. This is a photo so that you can see that this is legitimately how we get our grain growth looking. We have these long grains here. When we have multi-pass welds, so we can build up welds through multiple passes and get, like, there's lots of passes there in order to build up strength. Okay, similar thing here. We can see multiple welds being put there to build up strength. Okay, now what I wanted to do before we move on, I wanted to talk about here. High carbon steels and some alloy steel are more challenging to weld, and they need to be cooled to stop martensite forming. Why is martensite bad? Super brittle. Yeah, so we deal with martensite by tempering. If we don't temper, then we're going to have problems. So this is why they say why. So for instance, there have been HSC questions or at least trial questions that have said, why would there be warnings on high carbon steels that say, warning, high carbon steel, do not weld? And the reason for that is because high carbon steel needs to be welded very carefully in order to prevent martensite forming, as martensite is very brittle and can cause sudden catastrophic failure. Okay, they talk about how we can deal with that. We can, in some high carbon steels, preheating may be necessary to stop martensite forming or cracks developing. Okay, so we can continue on with our exam. Okay, there we go. A top view and a partially completed front view of a locking cap are shown. Project a half section front view of the locking cap using the partially completed view provided. Okay, so we can see here we have a locking cap, right? It's a shape, and what we're looking at here for details is, let's see if I can find this in the book. This symbol here, right, this U-shaped thing is a spot facing. Now, I'll show you where we've talked about in the book. It might take me a second. There you go, past it. Okay, so this is where we talked about spot facings. So in this case here, we can see that this shape is 15 millimeters diameter is the inner diameter. Then there's a spot facing, which is 30 millimeters diameter, that goes 15 millimeters down. Right? And that would be how we draw the spot facing. In this case, we have the same thing except it's a countersink. And the symbol for countersinks is this V, and we give the angle of the countersink, usually 90 degrees. Okay. Now, we don't need that anymore. I included before the exam a photo. Now, this is one that I had drawn up previously when I talked about it after using it in a different exam, where I gave the answers. So this is I included this as something, but I want to remind you that this was in the Punzit drawing book, where I said that I'd be taking drawings from the Punzit drawing book. If you went and did every single drawing in the drawing book, there would be no surprises for you. So let's have a look at what that answer looks like. I don't think new Facebook will let me. You can see the hole? Excellent. Okay, so we have discussed this, but we'll talk about it again. This is called PCD, pitch circle diameter. We're looking for the exam again. So it says it here. The answers, I'll show you again here. That's the answer. Now, if you draw it left or right, it doesn't matter which side you draw it. If you drew the mirror image of that, that would be fine. Now, I think, I'll be honest, I think I've missed a line, right? Because it said, okay, we'll come back to that. I'm going to be honest, I think I've missed a line. The line I have missed is this line here. Yeah? I've missed that line. If you look on my drawing. Now, this was a past HSC question, so I should be able to find it. Was it a past HSC question? It may have been a past trial. I might not be able to find an answer easily. Okay, so the question, I have two questions. So the question is, why do you only show half of it? And the other question is, why are you showing it through the hole? Why aren't you showing it through this center line as it's shown there? Right, and the reason for that is when we draw shapes, we draw them as interestingly as possible. Right, we try to include as much interesting stuff as possible. I think we're right at the back of the book. Okay, so when I first went through the my drawings book, this is my drawings book, right? It talks about in the Australian standard here how we're supposed to section things correctly and how we're supposed to draw things correctly. So first thing it says is draw at 45 degrees if at all possible. Right? If you have different materials, draw the angling in different directions. Don't, it says draw at 45 degrees. This case, drawing at 45 degrees would be confusing. Don't do that, go the other direction. If you need to go at 60 degrees in order to not be confusing, do that. Okay, then it says here, we want to draw, when we're talking about PCD, right, pitch circle diameter, we want to go in the most interesting way possible. We want to go through, so we look at how we're going through this circle, and then we're moving along, we're going through this circle, and then we go back out through the web. Now, I don't want to give you too much information because I'm going to get you to go through this year's trial, but a thing that's important is you can see here that it's sectioned that web. Can you see how it's sectioned? There's this section here, right, the stiffener. Can you see how they've sectioned that stiffener? Now, I know that the Australian standard says that you can do that. Somewhere in here I have a gif of Taylor Swift saying, don't do that like ever, right? Ever. In this subject, right, for the markers will expect you not to section through webs. And I thought, I know I've said that, but I just want to make sure, so I didn't use the question from the most recent trial. Instead, I went for one that I knew was in the book, which I said I would do, that I would give you something from the book. Okay, so what the idea is that we go through in this direction, and I'll show you what that looks like here. If we have this shape here, we go through the interesting stuff, right? We go through the circle, we go through the stiffener or the web, we go through the locking, I don't know, bayonet fitting or whatever we're going to call that. Again, we're going through the stiffener and then back through the circle. And so what we get is we should want to have an answer that looks like this and not an answer that looks like this. Yeah, don't do that. Yeah, because that is confusing. that is going to make it harder for the people building your object to figure out what's going on. Yeah, we always want to go in the direction of the interesting things. Yeah? Okay, so I can see this is something we're going to work on later. The fact I'll say here is that everybody did this badly, which is probably an indictment on me more than anything else. Yeah, I see 2 hands, just 1 second. The point I'll say to give you some reassurance is if everyone did badly, it effectively just reduces the value of the whole question. So everyone is equally, the rising tide lifts all boats. The same thing happens when the tide goes out. Okay, who's going first with the questions? Go.
So, even though it says half section from A to A, we should just do it. I don't know, that just seems...
Excellent. I'll come back to that. Okay, go. Exactly the same question? Great. Okay, so what I wanted to talk about before I continue further on is, so when it says half section, right? So half section, Nick, right? You said, so if we section, we just cut across the whole thing, right? We just remove half of the whole object. If we half section something, it's as though we just remove 1/4, right? We just remove this 1/4. Now, I just want to answer the question that was just asked. Even though it says from section A to A, why did we still go through this circle? Because of these 3 letters, P, C, D. Pitch, circle, diameter, which just means that we always show, if something says PCD, we show it through that section, right? We rotate the interesting thing, we rotate that part of the drawing through the section line.
What does that mean?
It just means that it's evenly spaced on the diameter. So it's rotationally centered. Yeah, so it's got a rotational axis of symmetry, and in order to reflect that, we show it in the section even if we don't cut through that section.
So is that 56 millimeters from the center?
Yes, that would be 56. Yes. Without getting a ruler to confirm that, the diameter is 56. Sorry, so yes, it's 28 from the side. Yeah, so because this is 40, that looks like 56. That looks about right. Okay, you had a question. Answered? Okay.
I actually didn't really get how there's 2 circles and stuff. Is that just different?
Okay, so I will show you now a picture of what this looks like conceptually. It looks like that. It's an octagon with a dip and then a hole drilled all the way through. And so what I talk about with PCD is that circles should be shown. So any sort of holes that are drilled, we typically will be PCD, where we show them through the section even if we don't cut through them. Similar thing for webs and stiffness. Now, generally speaking, like I said, I think the highest marks I gave was 3 marks. What am I looking for? Even if you had got that wrong, you would have only lost 1 mark. What I'm looking for is, first of all, that you showed a half section and not a full section. I'm looking for the fact that you knew how to hatch, right? So you're drawing lines that are lighter. So I want to see a difference in line width, right? I want to see that lighter line, and I want to see it at consistent 45 degree angle. Now, if you didn't do it at 45 degrees, I wouldn't necessarily have taken that mark off. What I want to see is a consistent angle with consistent spacing at a lighter line. So that was a mark. I wanted to see a center line. Pretty much as long as you drew a center line somewhere on the object, at least it showed me that you understand that you need to draw center lines. So collectively, I mean, that's 3 marks straight away, right, that I was looking to give. What else did I, just to go back? So if you drew, so half section, right, if you just drew a line on one side and some amount of sectioning on the other side, boom, that's 1 mark. If you showed me that you knew how to section properly with 45 degree lines, even spacing at a lighter line width, that was another mark. If you drew it with a center line, that was another mark. Right, 3 marks straight away. Then after that, what am I looking for the remaining 2 marks? I'm looking for the spot facing and I'm looking for the PCD. Yes.
Would you do a center line on the other side?
If you drew a yes. So I didn't in this case, but yeah, again, another. There should probably be a center line through there. Yeah. So I think that's identified two things I got wrong. Now, like I said, I don't think this is a HSC question. Otherwise, I would have included the HSC question, the HSC answer here. With trial questions, it may take me a while to find the trial answer. Yep. What's up?
You're talking about like rotating the holes, right?
Around
the 56 diameter.
Yep.
Why would you just rotate the holes and not like the rest of the octagon as well?
Because the holes are what are listed as PCD.
So it doesn't really matter where the holes are at all.
It's the fact that the holes are labelled as PCD.
Okay.
Yeah?
Yeah.
Okay. Now, just as I look at this photo, it looks like I used this in the prelim in 2000 and... I don't know if that's a 6 or an 8, but did I give that to you as a past prelim? 2016, I don't know, I'll have to look at that. I guess it doesn't matter to you guys now. Okay, so what are we going to next? Okay, we're on to aeronautical questions. Okay. Aeroplane propellers produce thrust. This forward movement combined with the shape of the wing, aerofoil, produces lift. With the aid of the diagram and the space below, explain the physical principles that cause this lift. Okay, so I'll show you where I discuss this in our Facebook page. There's got to be a faster way of doing this. Here we go. Took a while as we flashed through some of our history. Okay, so let's have a look. What am I looking for here? How many marks is this? 2 or 3? 3. Okay. So I want a labeled sketch, right? Now the labeling could be as little as LP and HP for low pressure and high pressure, right? That's the minimum I'd need. But as we have a look, okay, so what we've got here is, these are the answers I will accept with various degrees of caveats, right? First of all, if you said the wing generates lift because the air above the wing has lower pressure than the air above the wing has lower pressure than the air below, pushing it up, yeah. I mean, draw a picture, draw the low and high pressure, I'd probably give you a mark for that, right? It's feeling pretty generous. If you said Bernoulli's principle means that the air above is going faster, which means that there's lower pressure, lower pressure than the air below, generating lift, I'm okay with that. Then, if you said a better answer even still is the angle of the wing means more air hits the bottom of the wing, right? And Bernoulli's principle means that the air above is going faster. This results in lower pressure above the wing than below, which generates lift. And the best answer would say the conservation of mass, momentum, and energy causes the wing to generate lift. The more air hits the bottom of the wing. The Bernoulli's principle means that the air above the wing is going faster. This results in a lower pressure above the wing, higher pressure below, which generates lift. That's the best answer. Now, if you just wrote the conservation of energy and momentum results in the wing going up, I probably gave you a mark for that, but I would have written that this is risky and that the HSC marker might not be as generous as I am, right? I think is pretty much what I wrote. Because you really need to establish that there's lower pressure above the wing. I think this is the fundamental key. Everything else builds upon this information, right? It doesn't subtract, it doesn't replace, it's not substitutional, right? You need to build on the idea that we're going to have, no matter what your explanation, there's always lower pressure above the wing. That lower pressure above the wing is what generates lift. Okay. in terms of pictures, I could find one, but I'm lazy. Yeah, I'll pause. I'll sigh for long enough that if I feel less lazy, future Luke might actually edit in a photo here. Not draw it up. There you go. Labeling. Okay. Aircraft is traveling at constant velocity at an incline of 19 degrees. The mass of the aircraft is 75 tons. Determine the magnitude of the lift in this situation. This is the easiest of these sorts of questions. I'm pretty sure this is a question directly taken from our album of questions. I really do. Oh, this is the way to do it. Just open, leave another window open. Go to albums, and in our albums we have drag. And let's see which question. I may have changed the numbers. There we go. I did change the numbers. So in the original question was 85 tons. I changed the question for you guys just to make it a little bit more interesting. So let's have a look at my working out. Oh, super clear there. Okay, so I draw an angle, a diagram like this. Oh, this is such a bad angle. We're just going to go to this one. I don't like that. I don't like that drawing though. Why don't I have a better photo? Okay, it actually looks better like that. Okay, so we draw a right. Yes, we good?
Yeah.
Yep. Okay, we draw a right angle triangle. The hypotenuse is vertical and down, right? The next longer side is lift, pointing up. Then the smaller side is thrust minus drag. Because the angle of attack is 19, that means this angle here is 19. This angle up here is 90. I'm not going to go through the geometry on that one. You're just going to have to say, you just have to trust me at this point, right? Corresponding angles, alternate angles and parallel lines will help you get halfway there. Now, if you know that value, you're just using trigonometry to find it. We want to find, in this case, the adjacent angle. Right, we want to find lift, which is adjacent. So we can say that adjacent equals the hypotenuse times cos theta, which in this case is, well, in our case, we're going to use a different formula because we use different numbers. Our number, how much is 75 tons in kilonewtons? 750 kilonewtons, right? So it's 750 kilonewtons cos times cos 19 gives us like 709. The number has to be close, but less than the hypotenuse, right? That's just simple estimation should be able to give us that, right? We look at a triangle and say, well, it can't be bigger than the hypotenuse, and it's going to be close to the hypotenuse. So where I saw people, I know one place they lost a mark because they forgot to multiply by gravity. Otherwise, most people got it or they had just no idea. Right, so I saw a lot of people write the too many guys formula, which it's similar to this formula but different, right? This is just its own formula. So okay, easiest of the questions in that that set of practice album. Okay, question 27. Unmanned aerial vehicles, also known as drones, are an area of aviation innovation. Explain the social benefit of the use of unmanned aerial vehicles. Okay, this is a Punzit original. I thought it was a pretty reasonable question. I thought for 3 marks, I just want to remind people that explained means cause and effect, right? How and why. So if you just listed 3 things, if you just said firefighting drones, tree planting drones, search and rescue drones, right? I can't give you 3 marks. I just can't. You have to show me cause and effect. Now, the fact is that you're asking for 3 marks here, so if you give me 2 good answers with cause and effect, I can give you 2 marks. Oh, sorry. If you give me no cause and effect, but you list me 3 things, I'll just give you 2, right? For the 3rd mark, I need cause and effect, right? Now, you could take one thing where you can say firefighting drones, right, provide a social benefit to both a social and environmental benefit in that they prevent the destruction of property and they prevent the destruction of natural habitat and ecosystems, I would probably give you 3 marks for that. Right? The reason for that is even though you've only picked one thing, you've expanded it and given me 2 different reasons. Right? Even though I've asked for a social benefit, you've given me environmental benefit. You could say, well, environmental conservation has its own social benefit. People can go hiking in see the koalas and that sort of stuff. If you, on the other hand, pick 2 different things. If you said delivery drones can be used to provide life-saving medication to people in remote areas, and also to be just as a matter of convenience to allow people to get their Amazon Prime purchases sooner, well, that's one thing with 2 very different social benefits. If you said that drones can be used for racing and that's just cool, and you said that drones can also be used in surveillance to prevent crime, well, they're 2 very different applications of drones. They're not even closely related, but I would give that as 2 answers. And you've said what the benefit is, that they're cool, right? That they provide a spectator amusement to spectators, and we've said that it prevents crime. Even though we didn't specify that it provides entertainment to spectators, the fact that you explained one of them would be enough for me to give you 3 marks. I'm really trying to give you marks, and I think that the HSC marker probably will too. Okay. There was a logic question in the trial that I received, and I believe it was unsolvable. I contacted Copeland to say to him I thought it was unsolvable. I was going to go and talk to everyone else on ESNet, and then I just decided that I'd rather just make this video and say that, because no one will ever watch my video. So what I did is I took a past HSC question, and is it in our folder? Let's have a look. Boy, will I feel as though I gave you an easy question if it was in your folder. Here's our albums, logic. Close. Very, very close. Hey, Nick. So we can see it's very close. So I took a question that's a past HSC question that was a multiple choice one, and then I've asked instead for 2 marks. Interesting. The differences are making you fill out the table. Yep. If we look at that question, I can actually show you the answers of how that works. So let's have a look. Let's see if that doesn't even look terrible when we zoom in. Okay. It's actually flipped. Ours is a mirror image. I tell you what, I did get it from a HSC somewhere. I don't know where, but I know because I made the not dots a little bit bigger to make it clearer. Okay. Let's assume that we're starting with A is on and B is off. Well, let's have a look. First, we go to the AND gate. Right, we know it's an AND gate because it looks like a D. Right? And
so that's a NAND gate because it's got a circle on the bottom.
Okay, true. I was going to refer to it separately as the not dot when we get to it. But you are 100% right. Thank you for clarity. I'm glad that the people listening to this video will be more informed because of you helping me out. Okay, so let's have a look. The bouncer says you both need to be on the list, right? It says only one of you on the list. I'm sorry, I can't let you in. But the not dot comes along. The manager, right? He says nah, flips it and reverses it, right? They're in, right? So it's a 1. On the other side, we have a NOR gate. So if we just treat it as an OR gate without the N, and then we put the N on the end, let's have a look. Hey, as long as Jimmy's on the list, I'll let you both in. I'll let Jimmy and his friend both in. Right, so one person is true, so this goes through as true. The not dot, on the other hand, flips it, reverses it, and now it's a 0. So now we get to the AND gate, just an AND gate, and it says, are they both 1? No, they're not both 1, so they don't get in. And so the end result is a 0. If you apply that through the rest of the permutations, right, you'll... so the reason, when you're doing this question, you might say, well, is that a lot of work? And my answer to that is, I don't think that's a huge amount of work. You have to do the iteration 3 times. The reason you have to do it 3 times is because this one and this one are the same. To demonstrate that they're the same, this and this are the same. Yeah, the same outcome. So if you're aware of that, that helps you to speed up that third one. I think even then it's pretty reasonable for 2 marks. I think this is actually based, I honestly believe this is based on a HSC question, just maybe a more recent one. More recent one that's one in our book. Okay, this is definitely based off, sorry for clapping, this is definitely a question that will be on, that was from a past HSC. So let's have a look. We talked a lot about this, which we may not have talked enough about drawing recently, and that's on me, but an indictment of my teaching. But we definitely talked a lot about this in our telecommunications. So if we look at our telecommunications here, we have a question from the 2019 paper, full working. We have the snippet from the book that relates to it, and we have a very similar question. I tell you what, when I went to marking, I don't know if I'm allowed to talk about marking that much, so I won't say too much on a recording. But there were some people who were upset about seeing this question on the 2019 question, right? I'll tell you that was a thing. And I said, nah, like at this point you had to be aware of it because there was a question in 2015, right? The 2015 kids, they had a reason to be upset, right? These days in 2019, not as much reason, right? You should now be expecting, this is the level of knowledge that's expected for the HSC. Okay, so let's have a look at it. The antenna. Well, I'll open the answers so you can see the answers, but without looking at it, the antenna picks up the signal, right? If you just said antenna receives signal, I'm happy with that. Capacitor, the fixed capacitor smooths out the signal, right? That's the answer I would give. The variable capacitor tunes the signal. Now, if we read the answer, it says, works in tandem with the coil to have the circuit resonate a signal frequency. This allows the circuit to detect a single frequency band instead of all possible frequencies. That's a great answer. Me, I would just be happy with if you wrote tunes the signal. I'm giving that a mark. Okay, earphones converts the signal to sound. Earth acts as a negative pole. Okay, so if you said it acts as a ground point to complete the circuit, happy with that. Gives the electrons somewhere to flow to. I'd give that. I get quite a few range of answers. If you said that the Earth exists there as a safety feature, I can't really give that, right? And I say that look, that is true. I guess if we're talking about large scale, electricity, but often we're talking about things that run off 1.5 volts, and even then, it's still it's not the purpose in this diagram. Right, earth wiring, which we've talked about extensively. Yeah, that is the earth in our 3-plug power points. That's why we have earthing there. The earthing on our power points, just to make that clear, I'm drawing a picture of the power points in Australia. This one here is the earth. That does not provide a negative pole. Yeah, it's worth saying, it's worth specifying. In Australia, we have a cable that provides the negative pole, a cable where the electrons flow to. And we also have an earth. The earth in the power point, it provides safety. The earth in this context is just to give the electricity somewhere to flow to. I hope that that's clear to everyone. If it's not, by all means, put up your hand to say, I don't get what you're talking about, puns. Okay, lastly, the signal diode. This is the crystal in the crystal radio, right? The crystal in the crystal radio, it rectifies the circuit, right? It removes the negative component of the circuit. What does it say here? It allows only positive current to flow through the circuit, rectifying it, right? Turning the received signal into a half waveform, which is capable of being rectified C-less. Okay, now let's have a look at what that looks like through the different ranges. Now, I thought it would have been cruel to have given you this question because this was a hard question, right? I felt as though the kids who got this one last year, they deserve to say, oh, that one was trickier than I thought. Now, we talked quite a fair bit about this, and I got, we talked about the, I thought I had actually videos, so obviously never made it to my Facebook. If someone reminds me, I'll get some videos where they talk about both receiving and transmitting AM radio. And so it's someone with an oscilloscope who, you know who it is? It's the guy who does the engineering videos, that engineering guy. He has some good videos on this. Just one second. Okay. So we kind of need to flick back and forth in order to show this question clearly. Okay. At point A, our signal looks like this. So where our signal, our original signal, our signal looked like this. When we put it through the amplitude modulation, what we do is we fill in that signal with lots and lots of AM frequency. And the reason for this is because an AM radio can lock in on a specific frequency. It can detect, it can focus with that variable capacitor. We can find a specific frequency. And you see how all of this is one frequency. Okay, once it passes through the diode, right, originally a crystal and crystal radio sets, what we get is the half waveform, right? Then, once we then pass it through point C, right, once we pass through point C, once it goes through this fixed capacitor, we can smooth out the wave, right? Smoothing out the wave removes the high and low component, right? Passing through C acts to smooth out the wave, giving us this line. And that then gives us a signal which can be played as audio. Okay, so I don't think that it's, at this point, given the HSC precedent, I would say it's very, very unlikely that you'll ever get a question on FM radio, right? I don't know anything about FM radio. I'm going to say that, on a recording that I may or may not put on the internet. And I would argue that given the syllabus, right, the syllabus says demonstrates basic understanding. I'm not going to get the syllabus up just to prove this point, but the syllabus says something along the lines of demonstrates basic understanding of radio modulation, right? This is a basic understanding modulation. Obviously, we need to be able to understand how other things modulate. And in the past, and if you're listening to this, I'm pretty sure other YouTube videos that I've posted have talked about other forms of modulation. I just thought this was a more interesting and a more difficult question that's going to be more challenging for you, give you a better idea of what to prepare for the HSC. Okay. Okay. Explain 2 advantages of optical fiber over copper wire for telecommunications. Again, we have the explain as cause and effect. So it's pretty similar to what we talked about with drones. The only difference here is I explain 2 advantages. So, does anyone want to give me one? Okay, a lot of people said bandwidth, right? Bandwidth comes in many ways. You could talk about, you can send more signal. You can send faster signal. It doesn't matter if you send more signal. It doesn't matter if you send faster signal. What matters is how many words per minute can I transmit across this signal, right? How many images can I transmit in this signal? How much data, how many ones and zeros can I put through this signal? Now, when we talk about bandwidth, we can talk about bandwidth per unit of area, right? We can say how much internet can I push through per 100 millimeter diameter, right? That's a question. Or you can say how much internet can I push through per dollar of cable, right? That's another way of phrasing it, right? How much data can I push through per dollar of cable? You could also say that the signal just travels faster through, as light it travels faster than electricity, right? Now we've talked about per unit of area. The benefit is about 70 times the benefit at the moment with current technologies sending optical fiber rather than copper, right? Per unit of area, we get about 70 times the bandwidth benefit. That's one explanation, right? So we can now to explain that we need to say optical fiber sends many times more data per second for the same area for the same cost than copper, right? This benefit means that we can have faster internet speeds. We can do more with our internet. We can have better streaming services. We can send high quality images. We can video chats, right? What's another benefit? I'm sure someone said it here. Why do banks want to have their own intranets? Better security, right? You can't tap an optical fiber network. You can tap a copper network. Right? Back in the days when you were trying to get Al Capone, I don't know if cell phones existed in time of Al Capone, what you could do is that a guy from the CIA or the FBI could just climb up. I'm using the American equivalents, obviously ASIO and ASIS in Australia. A guy could climb up a telegraph pole, or a woman, I imagine, could climb up a telegraph pole. They could just put a device on the wire and you could just listen to what was happening on the phone. Right? These days you can't do that when you're using optical fiber technologies. Okay. Describe the function and benefit of multiplexing. Okay, so what is the function of multiplex? The function of multifit. How does multiplexing work? Yes. Yep. Okay, well, this is our last question, so I'm going to just finish this one off and say, okay, we can send multiple frequencies on the same wire, right? If I see something along those lines, I'll give you that answer, right? Where we can combine our signal to provide multiple signals on the same wire. What is the benefit? The benefit is we can have increased bandwidth, right? The benefit is that we can have more signal, we can have more internet, we can send more cat videos on the same signal. Now, in terms of optical fiber, I asked you to do homework on this, where I talked about there's 3 types of multiplexing that we use for optical fiber. What are they? Let's see how quickly I can find in the textbook. Before the bell.
Can we do it this time?
Yes. Okay. Stepped index, graded index, and mono. What do they call the mono one? Okay, here we go. Single mode fiber optic, stepped index, and graded index. Basically, no one really uses stepped index. We use mono and graded. The advantage, I think we talked about this in some detail previously, but from memory, it's that we can send more bandwidth over a shorter area with graded index. If we need something that needs to be very reliable over a long distance, like university campuses and things, then you use single mode optical fiber. Okay. That is the paper. Now, that'll be it for this recording, and I'll just talk briefly before you guys go for the day.